Hello everyone and welcome. In this last video of the data preprocessing mini section, we will be looking at data augmentation. So, let's jump in. Data augmentation, as we mentioned in a previous video, is essentially a strategy to improve the diversity of your dataset used for the training of machine learning models. This is done by artificially creating new images by making slight alterations to your existing data. More variability in the data means that the model can generalize better when it comes across new, unseen data. This is especially important in tasks like image recognition, where the angle, lighting, or background can change. As we will see later, data augmentation leads to improved model performance and capabilities. Imagine teaching a child to recognize a cat. If they only see the cat from one angle, say the front, and in one lighting, they might struggle to recognize the cat when they are looking at it from the side or the back or in a different setting. By providing different angles and different background settings with data augmentation, we help a computer model truly understand what is there in an image. Now, that we know what data augmentation is and what its benefits are, how do we actually perform data augmentation? Well, one way to perform data augmentation is to go out into the real world and collect more images. But this can be both time-consuming and expensive. So, let's look at some methods to artificially create new data. The first one is color tuning. Altering colors can train the model to recognize objects with varying color profiles. For example, if a model is given only images of a red apple, it may fail to recognize some of the South African and the US varieties, which are green and golden in color respectively. Next method is brightness enhancement. Adjusting the brightness helps the model handle different lighting conditions. Another method is contrast tuning, where enhancement is done to the differences between dark and light areas of the image. Next is grayscaling. Grayscaling simplifies the image, helping the model to focus more on the shape and texture rather than the color. Yet another technique is rotation, where we rotate the image by a few degrees clockwise or anti-clockwise. Another popular technique is zooming, which allows the model to learn from different scales. Flipping or mirroring images vertically or horizontally helps the model in understanding symmetrical properties. And finally, we have cropping, which helps the model to focus on different parts of an image by cutting parts away. Each of these techniques tweaks the data in a way that expands the diversity without complicating the process through collection of new data. This not only saves cost and time, but also makes your machine learning model more robust and accurate. To sum up, data augmentation is a powerful technique that helps ensure your models perform well in the real world when facing real-world variables. Being proficient in this technique will help you build better models, so learn it well. And that is all for this video. In the next video, we will look at the different types of machine learning algorithms. See you there.